garage, and I thought it was time maybe just to give a quick little update about what is going on around the house, around the shop, and with some of the different projects that I have going on. So let's take a couple minutes to see what we have going on here. What gave me an idea to make this video is I was working on the chiller, and I've been using it regularly for the past, I'm going to say 6 months now. Since we finished the assembly of it, it has been working really well. I'll take you through a couple of the little changes that I've had to do to improve it and make it more reliable as far as its operation. From the original design, it's actually in more or less the same state. So a couple things that I had to do, it's a little bit messy, but you'll notice on the side here, I have a PID controller. That is to replace the PID input that I had going to the ESP32 and going into Home Assistant, which is the platform that I'm using to control this. The reason I went with the PID controller externally is I was getting too much noise coming in on the temperature sensor down in the bottom of the tank there. And the temperatures were varying wildly, and I would say a lot of that was due to the compressor switching on and off. It was just creating electrical noise in the area. And so these units here, this one in particular is the Rex C100. It's a relay output. So all I'm doing is using that to read that temperature sensor and then dry contact into the ESP32 to basically trigger the automations that I have running for that. That was one of the first changes that I had to make. After that, inside there is that relay board. It basically converts the low level 3.3 volts of the ESP32 output to something usable. So there are a bank of 4 relays in there, 1, 2, 3, 4. And originally I was driving the different functions of the chiller. So the fan, the compressor in particular, and the pumps and whatnot. And those relays are rated for 10 amps. And for the most part, they are really good, actually. They run the fan, they run the pump. The only issue they had is they ended up, I guess, burning out the contacts that are used for the compressor. And the compressor is a pretty high inductive load, so when it's switching on and off, it ended up burning those contacts or basically fusing them shut to a point where the compressor never shut off, and that was not a good situation. So I ended up replacing that controller, and I still use the outputs of that new board there, but it's actually driving one of these 12-volt relays instead. And I'm actually using both contacts on this relay to actually give me a little bit more current carrying capacities. That was one of the changes that I've made to actually, improve the function of the compressor switching on and off. And lastly, so after running this for a while, just with strictly water in the reservoir, I found that to achieve the set point temperature that I wanted this to be right around 3 or 4 degrees Celsius when it's operating, and I wanted to have a fairly tight delta between that. So I want it to go plus 1 degree Celsius and minus 1 degree Celsius. And the refrigerant in the chiller system was actually icing up the coil here. So the quick fix for that, because I wanted to maintain the set point temperature and the delta, is you'll see all the pink in the water here. I just added a little bit of the winter antifreeze for plumbing, and basically we're just lowering the freeze point of the water a little bit. We're not going for full freeze protection. So out of the 65 liters we have here, I think it was about 10 liters of the plumbing antifreeze, and basically that lowered our freeze point down to about -10, which is just enough so that the coil doesn't freeze up into a block of ice. We get good thermal transfer, and then the system actually works pretty well. So those are some of the little improvements that I've made on this. Otherwise, it's been running really well. I'm running this sometimes maybe once a week for a couple hours, and it cycles on and off. So it'll run for about 20 minutes, and then it'll cycle off for about 20 minutes. Of course, the water circulation pump is always running through the heat exchanger that is inside the house. And so that's why this is outside, and there's 2 lines that go inside to that heat exchanger. It's basically just a copper tube that's in a coil in the... Overall, this is working really well. It's very reliable. I haven't had any other issues aside from those 3 little kind of tweaks that I've done. And I would say, yeah, this is a great successful project here. And you'll also notice that I have all of the water removed from the reservoir tank. I just want to get this unit cleaned up and basically stored away for summer. I'm not going to be using it as much because we go out and do other things at the cottage, camping, etc. So it would basically just sit here full of water and get scuzzy. So that's what I am doing here. So you will have to excuse me that it is so windy outside. We've actually had a really nice spring so far. And today is actually one of the colder days where we've had the first rain in probably, a good month. So it's a welcome break. We've had a lot of really hot days in the 30s and plus. So yeah, today's only +5 out. It's a little more winter-like. We saw a couple little flakes falling down, but like I said, that's kind of welcome right now. So something else I've been working on, we'll take a look here, is the front side of the camper. This fiberglass cap on the camper was actually in pretty rough shape. All of the varnish, the gel coat on the fiberglass had actually deteriorated to a point it looked like garbage. And I really didn't like bringing it to a campground looking like that. So what I ended up doing is stripping all of that down, and then once I got all of that clear coat varnish removed from it and all of the decals removed from it, I ended up wet sanding it with 220, and then I followed up with a 400. And the next step, now that it's ready to go, is we're going to apply an automotive grade vinyl wrap to it, and that should give us a really nice finish. So all the scratches here that you see, these are all just minor surface scratches. Overall, it's very smooth, and it'll take that vinyl wrap really well. So that's going to be something that I'm going to be doing in the next couple weeks, get that finished up. Something else, going back to the PTV build, something else that I wanted to do for quite a while, and I've been slowly plucking away at it. I finally will get some time, maybe today or tomorrow, to work on this, is to get those front wheels on the PTV upgraded to something that's going to be a little bit more durable. The reason I want to do this is, I think I mentioned in the finale build there, those front wheels were kind of popping off the bearings, and I came up with a solution. It might be a two-part solution. We'll see how well this first kind of setup works, and if we need to, we can move on to the next step. But yeah, let's take a look at that now. So I do have the PTV in storage under the solar array. The solar array actually makes for a great sheltered storage area. Keeps a lot of the UV off of anything that you have stored under here. So to take a look at this front wheel here, this is basically where we were having all those issues. All of that leading terrain that we are coming across is getting bombarded onto these wheels here, and these were actually just flopping right off of those bearings inside there. And I really want to get a wider wheel that will give us a little bit more surface area. It'll also give us a little bit more ability to resist this wheel from kind of wanting to tilt to either side inside of the track there. And so the plan, and what I basically went ahead and done, is I've ordered, this is a piece of aluminum. It is 6 inches in diameter. It's exactly 1 inch thick. And what we're going to do is turn this blank of aluminum into a new wheel. So what we'll end up doing is drilling a hole in the middle, machining that out on the lathe to accept these 1 inch bearings. And you'll note that they have a little flange on them. And so once we get these pressed into this new wheel from either side, so there'll actually be 2 of these, one from each side, the flange is what's going to keep the bearings aligned in that new wheel, and then these are going to sit on that axle, and this is going to prevent this wheel from wanting to bend either way anymore. What we'll end up doing is machining down the outside diameter to match exactly what we have with this wheel here, so that the diameter is the same, the way that the track rides will be exactly the same. And I think that'll be a good solution for making these front tires a little bit more durable. So the other thing that I was hinting on is, if we need to, I'm going to try these just as an aluminum wheel in this place to start. If we need to, what I am somewhat prepared to do is to machine the wheel face of this aluminum blank, so that we could actually cast on a piece of rubber and make our own rubber cast on an aluminum rim. And that might be a little bit more forgiving as far as taking some impact. With the aluminum wheel, it's going to be basically direct impact between the ground, and that wheel there is all going to be absorbed by this rubber track. It might be okay for a while, and it might be something that we want to tackle later on, but for now, what I really would like to do is get this set up so that we don't have to worry about these wheels popping off anymore. Having said that, we are going to head into the garage. We're going to get these aluminum blanks marked up, and we're going to start to machine them to become the new wheels for the front of the PTV tracks. First thing that we need to do with these aluminum blanks here is get the centers marked, just a rough center marked, so that when we put these into the lathe, we're going to have to use the 4-jaw chuck. The 3-jaw will not hold these as it is, so we will just need a way to basically get that blank centered in the 4-jaw chuck well enough so that we can actually drill out. We need to end up machining a 2-inch hole for those bearings, so we'll use like a hole saw just to hog out maybe an 1.5-inch hole in the center here, and then we can go ahead and finish that inside bore. And then once we've got that done, we'll switch back to the 3-jaw chuck. We'll use the internal grabbers on it, and then we can machine down the outside diameter of this. So this is 6 inches. The wheels on that track setup are 5.65, so we can take off quite a bit of material. And the reason that it doesn't need to be perfectly centered when we start is that we are taking off so much material off the outside edge here that we will basically be realigning the outer edge to the inner bore, and that won't be an issue. If we were wanting to use this as exactly 6-inch outside diameter, we would spend a lot more time finding the true center of this blank. But for our purposes, we're just going to use a caliper set up for 3 inches. We'll do a couple marks like this, and as you can see, right there is our center. That'll be close enough for what we're doing, and we can get to boring out this inside diameter. We are out in the shed now. We got to get the lathe set up. So like I'd mentioned previously, the 3-jaw chuck is just not big enough to be able to accept the 6-inch blank on there. So what we're going to do is remove that. We will get the 4-jaw chuck there in place, and then we're going to use the tailstock with the center to actually just align this on the 4-jaw, and that'll be close enough. Sometimes you just got to be aware of what your tolerance requirements are, and in this case, well, we know that we don't need to go to the nth degree to get that centered in that 4-jaw chuck, just because it really has no benefit to us later on. So like I said, we're going to get the tailstock set up, we're going to get the 4-jaw chuck in place, and then start to drill out the inside of that blank there. Got our 4-jaw chuck in place. We've got our chunk of 6-inch diameter, 1-inch thick aluminum, and I just used just something that had a pointy center to it to basically hold the blank in those jaws while I tighten them in place. And just to give you a little bit of an idea of how close it is, again, this is totally irrelevant because we're going to be remachining this outside diameter in relation to the inside diameter at a later point. So this is totally irrelevant, but just to give you an idea how close we are. So we're, I think, at the bottom of the range, right around 38 on the dial there, and we go up to 60. So 20 thou, not bad. I mean, just by eyeballing it, I'd say that's a pretty good range. So like I said, we're not even going to worry about that. I just wanted to give an idea of how close we can get just with, you know, eyeballing it and not really going any further. So I'm going to take the dial indicator off. We are going to switch out this reamer here into, we're going to put a hole saw in there actually, because rather than using a drill bit where all of the spoils, the cuttings from that hole just get wasted, we can drill out what could potentially be a useful round circle of aluminum, and we could use it for some other project later on. So I am the king of keeping junk around, and that's how we do it. Managed to get the hole roughed in this first piece here. So here is the, oh, there was the core. Here is the core. It's a nice little, I'm going to say that's about 1 3/8 diameter. I opted to not use the center bit in the hole saw just so that this could be a little more usable. If I need a hole in the middle, well, I can just put it in the lathe here and drill that out as required. So I'm not really committed to any size of hole there for now. And yeah, a couple of these kicking around might be useful at some point in the future. So anyway, we're done with the hole saw now. What I will do is get the boring bar set up. We will finish this inside hole to, those bearings are pretty much exactly 2 inches outside diameter. So we'll underbore that just by a couple thou so we can get a nice tight friction fit. And then once we're done with that, we'll move on to the other 3. So it'll be a kind of a rinse and repeat after that. So got this inside bore finished. It turned out really nice, and so the next step is to move on to boring out, rough boring, and then finish boring the other 3 blank pieces. This is the 4th blank that we have drilled out. The other 3 are all ready to go here. So the next step we need to do is remove the 4-jaw chuck. We don't need that any longer. We will put the 3-jaw chuck in. We'll use the inside teeth on that to grab from the inside of this finished bore, and then we will go ahead, turn our finished outside diameter. We will just face these so they look a little bit nicer. Ease the edges, round them over just a tiny bit, just so that they're not so sharp, and then that will be our wheel as it is for now. Have our 3-jaw chuck back in. We've got our inside chuck jaws holding our piece from the inside, that hole that we bored. So we are going to true up the outside diameter of this blank now to the finished diameter, the same outside diameter as on the PTV out there. And once we've got that done, like I said, we're going to just face these down to clean them up, and then basically these will be done. So got to do this 4 times. We're going to turn this outside diameter down to 5.65. These are 6 right now, so we don't have to take off a lot, but well, the battery in my phone is running low, so I probably won't get to do time-lapse for finishing these other 3 blanks, but this is what we have accomplished. So what I did is I started by turning the outside diameter to 5.65 inches, as I had mentioned previously. Then what I did is I faced this just to get it true. And then after that, I just started to cut this relief out here. It just makes the wheel look like it has a little bit more, I don't know, interest to it. The reason I didn't go further to the edge here is because eventually what I might end up doing is machining these back down to 5 inches. That's a little bit of waste of material. But then if we're going to cast some of that polyurethane rubber as a tread around here, we will make up that difference with the urethane. So I have to take off more of this material, but I wouldn't want that 5 inches ending up too close to this edge here, so I left a good generous amount. But overall, that is our wheel. That is how it's going to look for now on the PTV. For now, I think this is going to work really well. These should be really heavy duty with these nice sealed flanged bearings. And the reason I went with the flanged bearings is basically once you put them in, there is nothing that will prevent them from kind of moving around in there, and they'll get kind of clamped in place, and that will hold them true to the wheel itself. So it just adds a little bit more, I'd say, rigidity to the overall setup. So again, this is what we are trying to do. I'm going to go ahead and get these other 3 blanks done, and we'll get the bearings in and look at getting this set up on the PTV. I managed to get these machined. I grabbed the battery pack so I could finish doing time-lapse on that, and I'd say they turned out really nice. So we have, as you can see here, a nice bevel on the inside. The little sides here have been kind of carved out, if you will, and even the outside edges here, these corners have been just eased so they won't cause too much damage to the tracks. So that is about all I had planned for these. Like I said, I'm undecided and whether or not I need to put like a urethane tread on these. Still can do that. There's nothing that would prevent me from that. Obviously, we can just pop the bearings out, put these back into the lathe and turn them down. And so when we do, if we were to do that, I should say, what we would do is obviously make the diameter a little bit smaller, but we would also go inside and cut a little bit of a feature so that that urethane rubber could actually like kind of key in or lock into the aluminum. That would help it kind of stay in place a little bit better. And yeah, something that I'm going to think about over maybe the summer here. Don't need to get to that immediately. The one thing I did want was to replace these wheels immediately because it's kind of undrivable. You don't know when those other wheels are going to pop off the rim or where they're going to pop off the rim, and then you get kind of stuck wherever you are. So that's, yeah, I'd say that's a wrap. Let's go outside and get these installed. go. We got the new wheels installed and they are looking pretty sharp. I think they're going to work out really well. They'll be able to take a ton of abuse just being as robust, rugged as they are. I don't think I will have any problems with these front wheels going forward. So one thing, or I guess two things to note, when I was installing these, the shaft that these ride on, it sits inside of a tube and it goes from side to side. And I just had to trim that down by about 1/4 inch so that when I put these end bolts in, it could actually sandwich the whole bearing and assembly up against that tube inside there, right there. And that's what provides a lot of that rigidity, and that turned out really good. The one thing I did notice is the diameter of that shaft it's not perfectly 1 inch anymore. It's kind of worn down a little bit, so it's probably like, I don't know, maybe a 32nd smaller than it should be. So that shaft will eventually need to get replaced, but I'd say for now that's going to be a non-issue. And really it's just a matter of getting a piece of 1 inch, it could be steel or aluminum, drill and tap the ends so that we can capture these wheels onto that shaft again as they are here, and then again good to go. So that was a pretty easy little project. I'd say all in all, to give you a dollar figure on these wheels here, each blank, I ordered it online because that was the best deal I could find. So each blank worked out to about $30 a piece after taxes and shipping to my door. And then each of the bearings, they're a little pricey, but I wanted this flange bearing. I paid about $8 for each of those bearings. Yeah, like it's a little pricey, but it's going to make sure that these wheels do not give me any issues in the future. So yeah, we're probably right around the $200 mark, 220 bucks to get these 4 wheels replaced. But overall, I'm very happy with how that worked out. Well, there we go. The unit is parked back under the solar panels, but yeah, there we go. Those wheels are pretty freaking wicked. They're gonna be able to really make this thing handle a lot better, not having to worry about them popping off at inopportune times. So yeah, I was gonna say that one looks like it is gonna come off, but the thing is, as you kind of steer back and forth one side to the other, the tracks do shift from one side to the other, so there is a little bit of play between them. They are not tight up against that row of lugs on the inside there. So just so you know. But overall, that is all I really wanted to get tackled in this video. I do have to work on the camper a bunch more, waiting for a little bit more of the material and parts to do that work. I will also be putting some solar panels on the top just so that we could potentially do a little bit of off-grid camping. That may be a possibility in the coming summer here. I might do a little bit of a video on that. There's not too much to it. A little bit of custom aluminum brackets that I'll use to attach those to the roof. But aside from that, that's all I have on this video. And the pace for uploading might be a little bit slower now that summer is right around the corner, and be obviously dealing with a lot more family things, but I will try and give you guys at least one update a month. I think that's about all I will be able to manage, just with everything else going on. So thanks for watching, and we'll see you soon.